So we're slowing down if the first derivative is greater than 0 and the second derivative is less than 0. And the rationale there is this means you're going forward. This means you're letting off the gas pedal. Your car isn't going forward as fast as it was a minute ago because your acceleration is negative. Or the opposite's true. If you're going backwards, which is what this means, and your acceleration is positive, it means you're slowing down, you're getting closer and closer to a positive velocity because your slopes are getting bigger. If you're speeding up, it's just the opposite. Instead of the first and second derivatives disagreeing, speeding up means the first and second derivatives agree. Okay, so we got to figure out where these first and second derivatives are positive or negative, and they can only switch from being positive or negative where they equal 0. So that's what you want to do for both the velocity and the acceleration. If you set that equal to solve, you get equal to 1 and negative 1. Then over here, there's some algebra we can do. We can combine like terms up here to make that a little simpler. We want to set that equal to 0 as well. And if you do that, you're and I kind of jumped over this step, but look, when you set this equal to 0, you're multiplying both sides by t squared plus 1 squared, right, to make it cancel out from the denominator. And when you multiply it to 0, it's just 0. So that just leaves a quick little equation to solve for t. Okay, and when you do something similar over here, you just got to expand this part and then find out where that equation equals 0. You might have to solve using the quadratic formula, okay? But this is what you're going to get when you multiply both sides by 1 plus t squared to the 4th power. And then if we expand that parentheses, it's 1 plus 2t squared plus t to the 4th. And then if you multiply those two parentheses together, you get 1 minus t to the 4th. And then if you distribute that negative 2t, and then combine like terms. So we got negative 2t to the 5th leading off the powers plus 4t to the 4th minus 4t to the 3rd. Nothing to combine actually, just putting it in descending order. Wow, that can't be right. I'm not going to ask a student to find out. Solve a fifth power equation. Let me see if I missed anything. Oh shoot. Yeah, it's in the simplifying. Up here. Look, we've got a 1 plus t squared. There's two of them. There's 1 plus t squared and there's 1 plus t squared to the 4th. So you can break that down to be 1 plus t squared to the 3rd power. Yeah, that makes it way easier. Okay, and then you want to set it equal to 0. You distribute that negative 2t. And then here, distribute that minus 4t to everything. Put your signs there. And then we've already explained why that's going to go away because you multiply the both sides. And then if we could simplify, minus 2t to the 3rd plus 4, that's 2t to the 3rd minus 6t. So factor out 2t. And then you want to solve. You're going to get t equals 0. t equals square root of 3, positive or negative when you solve that equation. Okay, so that's all the places where it can switch direction. So for velocity, let's see, do we care? I don't think we care about negative time. Yeah, because that'd be going backwards in time. So for velocity, there's only one place we're really thinking about. So you want to try to plug in 0.5 to see if it's positive or negative between these two. So we plug 0.5 into your velocity function. 0.5 squared is going to give you 0.25. 1 minus 0.25. That's going to give you a positive number up top and a positive number on bottom. We don't care what the actual number is. We just want to know the sign. It's positive between 0 and 1. And if you try plugging in 2, you're going to get a negative up top and a positive on bottom. So negative divided by positive gives you a negative. So those are our signs for velocity. Here's our signs for acceleration. There's two places we're really concerned about. We don't care about negative square root of 3 because we don't care about backwards in time. 0 and square root of 3. So again, you want to test numbers to the left and to the right. Number to the left could be t equal to 1. If you put t equals 1 into your acceleration function, let's consider the simplified one where we made those things cancel out. Bottom's definitely going to be positive because 1 plus 1 squared, it's all going to be positive. Up top, that's 2. 2 times negative 2 gives us negative 4. And 1 minus 1 gives us 0. 0 times all this is going to be 0. We're going to get a negative up top. So negative divided by positive will give us a negative. If we plugged in a number between these two, we got a negative. And then try plugging in 2 and see whether that gives you a positive or negative. If you do that, you're going to get a positive in the bottom again, plugging in 2 there. And the top, let's see, that gives us a negative term. Negative times a negative gives us positive. Oh, how big is that going to be, though? Because that will matter. If you plug in 2, 2 squared is 4. 1 minus 4 is negative 3. Negative 3 times negative 4 times 2. Positive 24, right? Because it's a negative times a negative makes a positive. And then if we plug in 2 over here, that's 5. That's negative. So it's going to be positive up top. So we just found out everything to the right is going to be positive. Okay, so like we said at the beginning, here's where t equals 1. The signs are opposite. One's positive, one's negative. So that means it's slowing down, like we said. Slowing down between 0 and 1. And then between 1 and square root of 3 on these two things, they match. So that means it's speeding up. And then square root of 3 to how long does this thing go for? I don't know. Does it say it's an end? If it doesn't say it's an end, square root of 3, the signs are opposite, so that means it's slowing down. So square root of 3 to infinity, it should be slowing down.